students, in this video we are going to discuss about dimensional analysis. Dimensional analysis. Dimensional analysis and its application. And its applications. Once again, my dear students, I am explaining the heading. In this video, we are going to discuss about dimensional analysis and its applications. Now, I would like to explain point by point with elaboration. Point number 1. A physical quantities A physical quantities can be added, can be added, or subtracted. Or subtracted, which have the same, dimensions. My dear students, this is very important point. Once again, I am repeating this point. I would like to give an example also too. A physical quantities can be added or subtracted which have the same dimensions. Now, I would like to give some example. Final velocity minus initial velocity final velocity minus initial velocity is m0 L t to the power of minus 1 minus m0 L t to the power of minus 1. My dear students, final velocity dimension formula, it is initial velocity dimension formula. Now tell me what we will get. We will get here velocity. That means here we will get velocity m0 L t to the power of minus 1. Okay, that means what we understood from this one, a physical quantities can be added or subtracted which have the same dimensions. This is very important. Okay, now I would like to give another example. Another example. L plus L is equal L only. Next, L minus L is equal L only. Next, similarly, L by L we will get 1, and also L into L gives L square. So these are the 4 points we have to remember. Once again I am repeating, L plus L is equal to L. L minus L is equal to L. L by L is equal to 1. L into L gives L square. These are the 4 points we have to remember. It will be repeated in our numericals. Now, point number 2. Dimension analysis. Dimensional analysis. Dimensional analysis helps us in deducing certain relations, among different physical quantities. Among different physical quantities. Once again I am for quantities and checking the derivations, checking the derivations comma accuracy and dimensional consistency. Dimensional consistency or homogeneity of various mathematical expressions. Mathematical expressions. My dear students, I would like to repeat this point. Please observe carefully. Dimensional analysis helps us in deducing, checking the relations. That means checking the relation means if velocity is removed from velocity, which physical quantity we will get. Okay, that is the example, this one. Among the different physical quantities and checking the derivations. Checking the derivation means speed by velocity, which physical quantity we will get. So checking the derivations and checking the derivations means final speed minus initial speed. What is the physical quantity we will get, that is also. And accuracy, whether the given physical quantity is correct or not, that is called accuracy. And dimensional consistency, whether the given physical quantity is correct or not. If correct, why? If it is not correct, why? So all these will call dimensional consistency. Or homogeneity. Homogeneity means if suppose x minus x, gives x only. Actually, we know that x minus x is equal to 0. But x minus x is equal to x we called as homogeneity. Suppose 2 minus 2 is equal to 2 called homogeneity. Actually, we know that 2 minus 2 is equal to 0. But 2 minus 2 is equal to 2. Then we can call as homogeneity. Homogeneity of various mathematical expressions. Okay, so now we are going to discuss about point number 3. When two or more physical quantities, two or more physical quantities physical quantities are are multiplied their units should be treated treated in the same manner in the same manner. Once again I am repeating this point, my dear students. When two or more physical quantities, that means L into L, are multiplied, their unit should be treated in the same manner. Okay, so this is the third point. Now we are going to for next concept. My dear students, our next concept is checking the dimensional consistency of equations. Here, I would like to explain point by point. Point number 1. The magnitude of physical quantity. The magnitude of physical quantity physical quantity the magnitude of physical quantity added together or subtracted or subtracted from one another. One another have same dimensions. Have same dimensions. Have same dimensions. Once again I am repeating this point. The magnitude of physical quantity added together or subtracted from one another have same dimensions. That means add or subtract add or subtract add or subtract similar physical quantities. Similar physical quantities. Similar physical quantities. Similar physical quantities gives same physical quantity. Gives same physical quantity. This principle is called this principle called principle of homogeneity. Principle of homogeneity of dimensions. Once again, I am repeating this point, my dear students. The magnitude of physical quantity added together. That means I would like to give an example. L added together plus L or subtracted from one another. Take once again same L plus take minus, subtract means minus L. Okay, L same one and another have the same dimensions. That means both have same dimensions. Both have same dimensions or subtract similar physical quantity gives the same physical quantity. Gives the same physical quantity is called principle of homogeneity of dimensions or principle of homogeneity. Now tell me 2 minus 2, 0. But 2 minus 2 is equal to 2. Then we can call as principle of homogeneity according to the physics. Now L plus L is equal to L. L minus L is equal to L, called as principle of homogeneity. This is very important. What is principle of homogeneity? If same dimension formulas added, we will get same dimension formula. If same quantity of dimension formula subtracted, we will get the same dimension formula, called as principle of homogeneity. This point is very important. It will be support in the numerical. Now, point number 2. Dimensions are customarily used as a preliminary test of the test of the consistency of an of an equation when there is some doubt about the correctness of the equation. Once again I am repeating the point. Dimensions are customarily used as a preliminary test of the consistency of an equation when there is some doubts about the correctness of the equations. Next, point number 3. The trigonometric comma logarithm logarithmic and exponential functions are dimensionless. What is meaning for that? And once again I am repeating this point. The trigonometric, comma, logarithmic and exponential functions are dimensionless. What is meaning for that one is trigonometric. That means sin theta. It has no dimension. Sin theta, cos theta, tan theta, it has no dimension. Similarly, logarithmic means log x, comma, log e to the power of x. These are called logarithmic. It has no dimensions. Similarly, exponential functions, that means e to the power of x. This is called exponential function. It is also no dimensions. Once again I am repeating, my dear students. The trigonometric functions, logarithmic functions and exponential functions are dimensionless. It has no dimensions. Now, point number 4. A pure number comma ratio of similar physical quantity similar physical quantities, comma, angle as the ratio ratio, comma, refractive index, refractive index, refractive index has no dimensions. Once again I am repeating this point, my dear students. A pure number, example 6 and 7 and so on, it has no dimensions. A pure number, ratio of similar physical quantity, that means L by L gives 1, that means it has also no dimension. No dimension. And also angle has the ratio, that means sin theta by x. It is also no dimension. Another example is also there. Sin theta by cos theta. It has also no dimension. And also refractive index. Mu is equal to velocity of light in air to the velocity of light in medium. It is also refractive index, denoted by small n is equal to mu, has no dimensions. Once again I am repeating this point, my dear students. A pure number, comma, ratio of the similar physical quantities, comma, angles as the ratio, comma, refractive index has no dimensions. This is the point number 4. This is the point number 4. I hope you understood these 4 points. However, thank you very much for watching this video. Thank you very much for watching this video. Thank you.